Hello, community. So great that you are back. Hey, careful if you're out there and you're using a distilled AI model. Why? You know, some days ago, March 2025, we had here from Anthropic here this new thinking tool. This is now improves Claude complex problem solving performance, and everybody was happy. And I was looking at this and I said, this is fantastic. Only there is something massively wrong with this. Do you spot it? Why the hell is the most expensive extended thinking Claude 3.7 Sonnet performance less than 50% of a Scratchpad and a prompt engineer version? How is this possible? I mean, just look at the prices, no? If I look at Claude Sonnet 3.7, no thinking here for a particular normed whatever, I have here a normalized $17 price. Beautiful. So this is here this blue line. This is here the base model. Now, if I take this base model and I just put in here a free Scratchpad and I do a prompt engineering, I can increase my performance, I don't know, significantly here. But if I look at here, the latest technology, Claude 3.7 Sonnet Extended Thinking, the performance is far below a prompt engineering and the price is more than double. And I thought, there's something wrong. What's happening here? How is it possible that for a solution that is half as good, has half the performance as this one, I pay double the price? This cannot be here correct. No, I mean, what is Anthropic doing? So I checked out OpenAI platform and I went for prompt engineering and I went in particular for the reasoning models, no? And here we have official OpenAI platform. When using reasoning model, describe the tasks to be done in terms of goals and desired outcomes rather than specific step-by-step instruction and how to accomplish the task. So don't tell here the reasoning system, the O1 or the O3, the steps what to do. Just tell them what you want and the system will do it. No? Vibe coding, yeah. And I looked even deeper OpenAI platform. If you look the new GPT 4.5 preview, the prompt, no? It has a particular system message, tells me OpenAI, no? Highly capable, beautiful, yes, think step by step through complex problems, provide clear and accurate answer, anticipate helpful follow-up information, and beautiful. And I said, this does not explain anything of this. So what do we have here? I have a video on Claude 3.7 Sonnet, this thinking model, and I show you here the example of the optimized prompt. And I told you that looking here at the thinking tool example 2, this looks like an in-context learning, no? This is just days ago. And I told you this, I put it here, I said, this is strange that this brings here this massive performance boost that goes beyond, 100% beyond Claude 3.7 extended thinking, that I pay more than double. So, we need here a spark of genius. So, short question. Is few-shot examples back for reasoning models? Remember, for the non-reasoning models, for the GPT-4, for the Omni, whatever, we did need few-shot examples in context learning, in our prompt structure, to improve the performance, so I have a guidance here for the reasoning. And then with the new reasoning models, especially O1, OpenAI said, hey, stop using things step by step. Do not give you any guidance. Those are the reasoning models. And now Anthropic tells us, hey, we reinvented here the thinking tool Scratchpad because we need few-shot examples. What's going on? Now, you remember, if you've seen my other videos, we have a zero-shot example, a one-shot example, and a few-shot examples. Normally, I go up to a 5-shot example demo. And yes, I'm interested in the few-shot examples. This line here, officially by Anthropic, by Claude, by Sonnet, this prompt here, what is it? 0, 1, few? I want to know more about this performance line. And I'm for sure not gonna pay here for the orange extended thinking performance line. Now, the reasoning model I'm interested in is open source. I don't want to pay 35 times more for, I don't know, an O1 or O3 or whatever. I want to go open source the O1. Now, luckily, from R1, we have distilled version 1.5b, 3b, 7b, 32b. And you remember in my last video, I built here already. I cannot wait for the official R2 model. I built my own single task R2. And I said, here's the video. And now I thought, hey, do I have to further optimize here the inside of this video here? So let's do the tests. It is easy. We have a question or a query here, a queue. Alice chooses here a set of positive integer. The Bob lists all finite non-empty sets B of positive integer with the property that the maximum element of B belongs to A. Bob list has 2024 sets. Find here the sum of the elements of A. And here you have now an R132B distilled version. And now look at this. And there's a brand new study from some beautiful cooperation between China and the US. And they analyze exactly that point. Look, they highlighted here in the thinking process here. Let me check. But wait, let's verify. Let's compute that. Wait, but let me double check. The initial answer was incorrect. The correct answer is this. So they come to a correct answer and say, but wait, let me think again. But wait, but let me check once more. And they looked at this now in detail over weeks and maybe months. And they said, this is strange because this R132B generates 1K thinking tokens across 15 different reasoning steps, if you count this, exhibiting here an extensive self-reflection pattern. And this is what you want. You want a system to be not conscious of itself, but in basic, you have some self-reflection. Hey, does it make sense what I'm calculating here? So the basic functionality we are checking here, no? And we see those phrases like wait, or let me check once more, and you want this. But there is a limit. And now they found here that despite reaching here the correct answer, also midway they were there. Look here, the correct answer is. And then they got in the autoaggressive token generation. They suddenly got here another, if you want, token to have another verification run after 1, 2, 3, 4 verification runs already. So what is happening here? We do have overthinking, massive overthinking. And you know what? Yes, you pay for the thinking token, for each and every token. Now, what a coincidence by the global industry. It has nothing to do about profit orientation. And they said, okay, so let's take the same question with a few shot chain of thought prompt, our in-context learning from years ago, where we had those non-reasoning test time compute models. And they do the same on R132B. Look, could be so simple. And they said, when prompted here in the same query with a few shot chain of thought, the same model produced only 420 thinking tokens, but also 12 reasoning steps. So we do have the complexity of the non-linear reasoning chain. But you know what? It's more than a 60% reduction in the token consumption and therefore in the price of the model. The model still engages here in the verification and the self-reflection. Let's check, wait, have a look at this. So we do have the basic functionality we're looking for, but not that we have overthinking. So what is now the new core idea? What were we doing here? We are testing now 3 basic prompts because, I want to see this prompt here from this performance. I don't want to go extended thinking. No, I want those prompts. So let's check them out. Now the team here, our Chinese and American friends, did it here for 3 basic prompts. The direct question, so only a question, you say return and you want an answer. The 0-shot chain of thought is your classical, hey AI, let's think step by step that we do, I don't know, since 5 years. And then we have those few shot chain of thought questions where we have an example question, an example answer for n times, how many few there are. And then we ask here the real question and the real answer. Everything okay? Perfect. Let's go to the fact. This is the study. This is a study here, March 25 from yesterday, 2025. This is here from, where are we? AI Safety of the Chinese Academy of Science, the University of California, the Shenzhen International Graduate School, Tsinghua University, okay, and University of Chinese Academy of Science. And they examined exactly, is chain of thought prompting a popular in-context learning method for chat LLMs, 2 years ago, still now necessary to enhance the reasoning capabilities of our reasoning LLMs, of our OpenAI O1, O3, DeepSeek R1, or whatever you have. So we have now the new R LLMs. And they looked at this and they say, if we have unguided, we do have overthinking. We have excessive reflection. This, wait, actually, perhaps, let me check again. No, let's come back again. I mean, great for the profit orientation of your global corporation, but we want fast, cheap, and better performance. Now, let me make this clear. We are only looking at a very particular set of distilled model. We are looking at DeepSeek R1, QN 1.5, QN 7, Llama 8B, QN 14B, and QN 32B. And if you see, how was this distillation done? I have a particular video on all the technical details you find here, so you see exactly how to do this. But something happens. And I'm glad that I put in the Llama, because you will see the difference now in the next minutes between the QN and the Llama. Have a look at this. So here we have the model, the R1, 1.5B, the 7B. This here, the 8B, is the Llama. All the other are the QN models, where we used here the distilled knowledge traces from the full R1, and we have a supervised fine-tuning on a 7B, 1.5B, QN, or an 8B Llama model. So, prompt is clear, no? Direct is more or less nothing. Zero shot is just, you say, hey, think step by step, and the few shot now is the interesting one. And we have, how many benchmarks? 1, 2, 3, 4, 5, 6 benchmarks. And here you have now the complete details. And this is amazing. Why? Have a look at this. Let's just focus here on SatMat. Now, the 1.5B, or a little tiny little execute, they have 47%. Great. We are talking about accuracy, by the way. With a zero shot, this goes up to 72, and with a few shot, I am close to 94%, which is real nice. And here you see now the performance improvement from a direct 1.5B, 47 to 81 for a direct prompt. And you see we can go up close to 97% already with a 7B model. So this is exceptionally nice. Interestingly, if we take an same category, an 8B Llama model, we go down. But why? Why do we go down with a Llama model? This has to do with the pre-training data set of the Llama and this particular post-training if it happened with Llama. So you see, we are really specific to the models. You cannot mix an insight from a QN model and say the same is true for a Llama model. They are not compatible here. Then we go to 14B, and yeah, for a 32B, we have 100%. Perfect. Absolute perfection. But if we go here for the simplest mathematical benchmark here, you see, let's just look at the direct, no? 5, 35, 78, 82, and then we stick with 82. Interesting. So going from 14B to 32B, there's not a lot of. Just if we go here to the 14B view shot, we have close to 90. But then interestingly, with a zero shot, come on, we have 92. There are some things that I cannot explain to you. I'm not aware what detail in the training data set of this particular models now induce this behavior if you just say zero shot chain of thought, hey, think step by step. Why suddenly this is better than a few shot chain of thought? There is something in the training data set that is the cause for this behavior, but I can't deep dive into the training data set of this model and really pinpoint the problem. But of course, we have here, if you think about a little bit more complex benchmark, AIM24. Now you see the direct, we have 3, then 6, then suddenly 36, then we have 6, and then we have 10. So the QN have kind of a linear improvement. But it looks that the Llama model my little llama model, was it coincidentally that it already saw maybe a little tiny part here of this benchmark before? Could this be? Because, I mean, for a 7B, it should be around 6, 7, 8, and 36 is really something special. And you know what? Even if you go to a zero-shot chain of thought for the llama model, the llama model falls down from 36% to 3. So just if you add, you have your query and then you said, think step by step, you fall from 36% to 3% accuracy with the same llama model. So we have an extreme sensitivity to the prompt. And even if you provide them some few shot examples, question and answers, it just goes up to 23%. So something is real strange here with the llama model. You see, it is so specific. It is so specific to the model family and even maybe down to the model class. Now, they looked here at a lot of different metrics. Accuracy is just what we had a look at. No? Then they looked at the specific number of thinking tokens. I showed you this at the beginning of this video, no? More than 1K, less than 60%. They also looked here, and this is now interesting, at the number of the reasoning steps and at the number of reflection points in the reasoning chain of our AI system. So how often some specific keywords, no? Like wait, or let me check, or or recalculate, or verifying, or whatever, no? This is kind of a key metric. They said, hey, we have now a focus because we want to quantify that this overthinking is really happening in those models, and this is not just an idea. So what they did, they looked now at each specific layer of those models. Here we have the Llama 8B, the layer 9. And they have here a heat map here on the left side. This is the attention logits before the softmax, averaged over all the heads per layer. And here on the right-hand side, you have the softmax normalized attention scores for the input sequence. And now look, and especially here at layer 26 here, look at what sensitive, where the attention goes to. It goes to ensure and wait. So we see in the calculation now of self-attention and everything in the specific layers, those, reflection words or self-verification words, they receive so much attention now from the model itself that they have here an outstanding performance. Therefore, the model now says, okay, I have to ensure, I have enough time to ensure, I have to wait, let me double check, I have to wait. So you see, the attention mechanism, there is something wrong, because this should not happen. Because we want to have a logical chain, 4, 5, 6, 7, but we don't want the attention only on the reflection point, on the verification, and after points where the system doubts itself. So they come back and says, hey, our 1.8b here shows that Llama model shows a higher attention logit and score for this reflection keywords, this wait, double check, compared here to the Llama base model. Supporting here really that there is here this overfitting happening. So we do have, calculating now the attention tensor structures, we have an excessive reflection on those specific tokens. And now the funny thing, the most interesting thing is that those reasoning LLM really appear to overfit to these reflection-related linguistic elements during their specialized distillation training, leading now to an inefficient reasoning. Because it just goes out in a loop to have 12 times a self-verification. This is not what we want. We want to have a complex chain of solutions, but not loops, just self-reflect and self-reflect. So this is really interesting to see this happening in this distilled version, and especially Llama seems to be very sensitive to this. And now comes really the amazing part. If we have now in our prompt some external chain of thought, these few short examples, they seem to have now this, that they provide here a structural guidance to the model. And this simple external chain of thought now that we have in the reasoning model overrides here this tendency for the inefficient reasoning of the excessive reflection by the higher attention logics. So we just need in our prompt now to provide here some few short examples, and the system is back on track. This is amazing. We sorted our reasoning LLMs are the latest technology. Perfect. Unbelievable. You pay double, you pay triple, you pay 10 times the normal price. And then we discover, because whatever happened, they have inefficient reasoning. It's amazing. Yeah, careful. Those results that I showed you are only valid for distilled LLMs. This is not valid for the R1 model, for the original R1 model. No? This is only happening when we have the R1 model. We distill now a lot of reasoning chains out of this full R1 model, and then we take this reasoning chains that we extracted as the input training data set to the smaller models, to the non-reasoning models, to a Llama 8B, to a QWEN model that is a non-reasoning model, non-reasoning meaning a non-test time compute scaling model. So in this process between those things, something happens here that causes overthinking. The self-attention mathematics has such a priority on those self-reflective words, and it is not corrected yet. So if you use today a distilled LLMs, be extra careful. But we have more data. Let's have a look at this. Yeah, all the different tests. If you're not familiar, these are the tests that they use. Look at this. It is really true because here we have the number of steps and the accuracy of the model. And now in red, you have here the direct, so you have no chain of thought, no COT, no few shot reasoning at all in the prompt. So you just have a query. This is the red one. Look, the 1.5B, the 14B, the 7B, the 32B, they are all below 10% accuracy. How is this possible after 40 steps of reasoning? Because we have this self-evaluation avalanche going on. Self-evaluate, self-evaluate, self-evaluate. If you provide in the prompt some few short examples, what you want the system to do in your prompt, look, then this is your performance. Hey, this is your performance. The 1.5B, the 7B, where you expect it to be, the 14B and the 32B above 40% accuracy. So if you use distilled model, watch out. With a very simple, I don't want to call it a trick, but you have to know it. If not, you are here and you're paying for those models. We just provide here a chain of thought in the prompt and you can have this performance. And it's even cheaper because you pay for each step. So this means this additional chain of thought for the reasoning model now regulates the token distribution in a way that it overrides the thinking. And I think this is amazing here now at the end of March 2025. Now they went even deeper. Look, here we have the model 1.5B, 7B, 14B, 32B, and they look now at the number of the reasoning steps. No? Looking at the reasoning, they said, okay, this is a reasoning step, and they said, okay, the next 2-3 lines are also a reasoning step, and they looked at how many reasoning steps are happening, and how does the number of reasoning steps correlate with the accuracy of the complete model in our reasoning LLMs. And they have here a simple mathematical benchmark and an even simpler mathematical benchmark. Why mathematics? Because you know exactly when it is true. If you have a mathematical formula, you know the result. While if you would go for, I don't know, a poetry, or a term, a technical term, you say, maybe you could interpret this and maybe the answer was correct because if you think about another circumstance, no, mathematics, listen, either this is the correct value or not, full stop. Let's look at this, the 1.5B. the number of steps, increase the performance, and then if we start with our self evaluation avalanche, the performance goes down. Interestingly, the tiniest model, the 1.5B, are absolute sensitive. You have to find here the golden zone here of the maximum number of steps for the best accuracy. And it is not more is better. If you go to higher models, you see that this curve kind of flattens out. No, we stay here, we saturate here at the maximum performance level. I think this is absolutely fascinating that they show this performance. But now we come to the main question. This is the reasoning step. But we, in the prompt, we have to put their examples, no? Question and answering pairs. I have to show the AI system what I want before I put in my question. So, how many of these question answering pairs should I put in? They examine this for all the different models. Hey, great big thank you to all of you for these experiments. And we can answer now how many few-shot examples are best. Now, for the distilled all-one models, we know the answer. The answer is 1. A one-shot chain of thought prompt delivers the best result independent of the model size. From a 1.5B to a 32B, it is just one example necessary in your prompt. If you have 2, you decrease the performance. Look, 5, you decrease the performance compared to only 1. Fascinating. Just giving the AI a hint, one example, and the AI will follow it. If you give it multiple examples, the probability distribution seems to widen and we encounter not the maximum performance. I think it's fascinating what we find out currently today in those days. So, a one-shot chain of thought prompt offers here a surprising effective balance of the guidance and increased flexibility for those distilled models. So it is easy. If you use a distilled model, this is something you have to think about. Otherwise, you lose massively performance. Careful, this is only valid for the R1, the Q1, and their quantized version. And I know that you use quantized distilled version. Why? Because I asked you this 10 days ago. I have now for multiple days here this suspicion there is something wrong. And now finally I can make this video. And 10 days ago I already asked you, hey, how do you use your R1? And 24% use R1 distilled model and close to 60% quantized distilled version. So for both of you groups here, there is now a beautiful solution to have a massive performance jump using your prompt a one-shot chain of thought example. It couldn't be easier with in-context learning to increase the performance of your system significantly. So this is it for today. I just wanted to show you, careful, if you use distilled AI systems in AI, there is now something you have to be careful for because otherwise you pay too much, you lose money, and you lose performance. But with this simple, careful implementation of a one-shot chain of thought, we have today, from yesterday, a brand new study showing us this is the way to go. If you enjoyed it, if you found it interesting, hey, why not subscribe? And I see you in my next video.